Okay, we're ready. All right, day 2, lesson 10-1. Okay, all right, there's only 2 slides, it's not much, but I will tell you this, the first slide doesn't take us very long, the second slide might take us, I don't know, 10 minutes. Okay, so what are we going to do? Today's job is to find the distance between a point and a line. Okay, that's all you have to do. Find the distance between a point and a line. Now, would you please make a quick sketch of this? Call this your point, x1, comma, y1. Call this your line, right there. And your job today is to find the distance between this point and this line, right there. Find that distance. Call that D. Okay. Now, how exactly are we going to do this? Well, I'm going to give you a formula today, and I'm just going to give it to you. I'm not going to show you how they came about getting this. We're just going to read the formula and look at the definition. All right, here we go. The distance between a point, x1, y1, and the line ax plus by plus c equals 0, okay, is going to be d equals such and such. Now, notice, please look back at this equation. Look at the equation. How did they write it? How is it written? In slope-intercept form? No. How is it written? Point-slope. No, that's not point-slope form. When they put the x term and the y term and the c term all on one side, yeah, we called it standard. So they're really putting it in standard form. So for you guys to actually use this formula, put it in standard form. Now, to be honest, standard form, the c value is usually over there, right? But notice they put it over with the x and the y term, okay? Now, I'm going to tell you something. Now, some of you won't do this and some of you will do this, but this is really nice. It is very nice if a, comma, b, comma, c happen to be what? Integers. Make them integers because if you make them integers, this formula is so easy to work with. Get your 1s and your 2s and your 3s. Don't work with fractions unless you just don't care. If you like fractions, go with it. To me, that just makes this really easy. Now, the a, the b, the c, right here, all this just comes right out of this formula right there. Okay? Where does the x1, y1 come from? Right here, the point. The point I gave you back here, that's where it comes from. Okay? All right, I don't want to do this problem. I want you to do it. Here's the problem. Find the distance between the point 0, 2 and the line 4x plus 3y equals 0. Find the distance between the point and the line. Okay? I am going to sketch it. You don't have to do this. You don't have to sketch it. Just, I'm going to do it. You plug this stuff into the formula. See what you get. All right, just so you know, this is what you're doing. I plotted the point 0, 2. I actually know what that line looks like. I solved it for y in my head, found the slope to be -3/4, found the y-intercept to be 0. I drew it. What are you doing? You're trying to figure out this right here. Give me the distance between this point and this line. Got it yet? Just coming around, checking it out. Ready?
I don't think I got the number.
Did you come in really late?
I might have.
Okay. Okay, now I'm coming around. If you have it, let me see it. Get there. No. Yes on the bottom, but no on the tops is wrong. That's 3 times 2. Okay. Otherwise, it looks really good. Yep. 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 Again.
615.
Yep. Yep. Oh, I don't even know if I have to do it. You think? I think everybody got it, except a couple people who just didn't get their notes quick enough. Okay, I'm going to do it just so it's on the video. So here we go. I'll do this kind of fast. This equation, what is the equation of this line? Oh, there it is right there. I'm sorry. I was thinking of the next problem. It's right here. We have the equation all set up. You know what we don't have? Where's that C value? Where's the C value if you don't see it? It's just 0, right? Without a C value, just put a 0 in that spot. So here's your A, here's your B, here's your C, and of course you have your point right there. So the formula is distance equals, up here, absolute value of A is 4, X is what? 0. B is 3, Y is 2, and then you've got your C value right there. So that's what you should have wrote on your paper. And then over what? Square root of A squared plus B squared. So A squared is 4 squared, B squared is, B, where's B? Right there. 3 squared. This is the only thing you have to do in there. 6, absolute value of 6 is 6. This is the square root of 25, which is 5. 6/5. Or you could have said what? Maybe 1.2, whatever you want to say. So how far is it from this point to this line? 1.2, 6/5. Notice what I did when I went from this point to this line. I put a what there?
Right angle?
Yeah, because if you want the distance to a line, you're going to go the shortest distance possible. You're going to go straight at it, and you're going to form a 90 every time. This would not be the distance, correct? From here to here. That's not the shortest possible route. You wouldn't do that. You would always form a right angle here. Okay, now that was supposed to be the quick one. Let's go to the next one. And here it is. 2 things to do. 1, find the altitude from vertex B to side AC. And 2, find the area. So we're going to do these 2 things. Find altitude first, area second. But hang on, let's read the top. And I do want you to sketch this. I told you I want you to sketch. Given the triangle with vertices A, 0, 0, B, 1, 5, C, 3, 1. You guys come and make a quick sketch of this stuff. 0, 0's here. 1, 5 is here. This is B. And C is 3, 1. Somewhere around here. Okay, there it is. All right. Find the altitude. Well, if I'm going to find the altitude from B to side AC, I start at B, I head towards AC, but where? How do I head towards AC?
Straight.
Straight down, like this? Straight down?
Well,
No, I don't think you want straight down. You want
to the midpoint.
not to the midpoint. Perpendicular. It's got to be perpendicular. So this is kind of weird because this is at an angle, so you've got to do almost something like this. Something like that would be the altitude, because the altitude must form what? a 90. Okay, you know, last week I taught this lesson to somebody, and they told me, oh, it's the midpoint. I just have to find the midpoint, right? No. That's not true. The altitude forms a right angle, so you've got to make it look like a right angle. So this is the distance from this point to the line. Now, use your formula you just learned on the other page. Distance from a point to a line. There's two things you need. You need the point, and you need what? What? The line, but what about the line? Okay, yeah. Colton, you're saying standard form, but you're saying also this. Colton's saying standard form, but he means you need an equation to line AC. Okay, so you have to do some stuff here, guys. If you want to look over here, I wrote you a little note. Slope. If you ever want to find slope, it's just rise over run. So if you have a picture, go ahead and do that. Here's the slope formula, in case you ever want to use the slope formula. If you want to write the equation of a line, you can do this, put it in slope-intercept form, or you can use point-slope form. This is Algebra 1 stuff. Probably Algebra 1 stuff you forgot about. But you've used it so many times, I think I can just show you and just let you go. So, will you do what for me? Find the equation. B is 1, 5. That's an easy one. This is considered the tough one. Get the equation. Just pretend AC goes forever. Find the equation for AC. If you have the equation, just let me give you the thumbs up, just so I can tell you to keep going. Did I read it? No? Okay. Anybody have the equation, just so I can look at it? Yeah, it is. Yeah. How'd you do it?
We don't have to make those to the
Perfect. That's such an easy.
Yeah.
Yeah. And the reason I have to tell you all this is because what if it didn't go through? What if it went through?
Oh.
Then you have to use 27. So this one is not that. It should. How'd you get negative 2? Oh, you're doing BC, aren't you? Yeah. Yep. And then it crosses at 0, so it's 1/3 x plus 0.
So then it's just y is 1 and x is 1/3.
Well, it is, but yet you've got to use this formula. You've got to have everything on one side. So move that over, or move the y over. So move the y over, it's 1/3 x plus 0 equals 0. So then the x is, or the a is 1/3, and the y is 1. But I don't like what comes factor, so I'm going to do something. Okay. Okay, just quick. Answer my question, please. How did you find the slope? Did you do this? Did you do slope formula? Or did you do rise over run? You did slope formula. Formula. Rise over run. Okay, hey guys, this is why I told you to sketch it. I told you to sketch it because you don't need the formula. You're going up 1, you're going what? Over 3. Doesn't that tell you right now that the slope is 1/3? And you know what? The slope formula will tell you that too, by the way. What other thing do you need to know to write the equation? B, the y-intercept. Well, what's the y-intercept of this line? 0. So B is 0. So really, guys, the equation is y equals 1/3 x plus 0, right? Now, if this was a harder problem and the y-intercept was like 1.4, 1.5, then I would have used point-slope form. Point-slope form will always get you the answer. It's just this is not needed in this problem. Now, ready? Come on over here. Put it in the correct form. What's the correct form? That is the correct form. Get everything equal to 0. Ax, by, c on one side. So here we go. I'm going to leave my x term on that side, move my y over here. So minus y. What is the c value? 0. Somebody in period 4 figured this out. The c value is always going to be what? Anybody figure that out? The c value is right there. It's the y-intercept. So, I mean, you don't have to know that, but it's kind of nice to know that. Now, I talked to Olivia about this. I said, I don't want my a to be 1/3. I'm going to do something. What am I going to do to this equation? Take it all times 3, says Colton. Colton's right. That would make x. That would make negative 3y. Plus, and finally 0, 0, right? There it is. Here's your A, here's your B, here's your C, and now you want the distance from B to segment AC. So, use your formula. Distance equals, okay, A, what is A? 1 times x1, 1, plus negative 3 times 5 plus 0, square root of a squared plus b squared. On the bottom, square root of 10. On the top, what'd you guys get? 14. I'm getting negative 14. Either you get negative 14 or you get positive 14. I got negative. The absolute value will turn that into 14 over square root of 10. Once I rationalize, I get this over that. And then I reduce it to get what? Say it again.
7 squared to 10.
There it is, yep. 7 squared root of 10 over 5. Hey, by the way, that is the, it says D, but it's really the what? Altitude. Okay, you just found the altitude of your triangle, right? Now remember, part B is coming. Part B, they want what? Area. Okay, how do you find the area of the triangle? Half the base times the height. But what's altitude? What's altitude again? It's just the height. So really you already have 2 out of 3 numbers. You have this, this. You just need the base. By the way, what's the base on the triangle? AC. Okay. All right, AC. All right. Here's A, 0, 0. Whoa, that's ugly. And here's C, 3, 1, wasn't it? 0, 0, 3, 1. How are you going to find the distance from here to here? Pythagorean theorem. It's not the way I want. That's not what I wanted him to say, but you can. The distance formula. That's what I wanted. Now, Colton says you can do the Pythagorean theorem. Do you guys agree with Colton? This leg squared plus this leg squared equals hypotenuse squared. Take the square root of both sides. Or you can do the distance formula. The distance formula, in case you forgot, which I'm sure you probably have, the distance formula is the square root of, these are just things you might want to write down, x2 minus x1, y2 minus y1. So the difference in the x's squared plus the difference in the y's squared, take the square root of it. Here we go. What x is when you subtract? It's this minus this squared plus, what would it be? 1 minus 0 squared. Oh, that's 3 squared. That's 9. I'm just going to write 9 instead. 9 plus 1. It's the square root of 10. By the way, what did I just find? That's the base. I just found the base. You just found the base of your triangle, which you'll go back up. You go back up, put it back in to your area formula, square root of 10 over 1. This should be easy for us. What's the square root of 10 times the square root of 10? 10 times 7? 70 over 2 times 1 times 5. What's the area of your triangle? 7 square units. Whoops. Units. Okay. Are you okay? Do you see where I got that answer? How I came about getting that answer? Okay. You know what? I'm just gonna say I'm done. But those formulas on the whiteboard, that is what you need to be successful at this lesson. So I'm going to write those on the next screen, so on the video you can see it, hear it, whatever. So if you want to write this down now, do it. If you don't want to write that down, you better know it. And you can just start your assignment. Okay? All right. I'm writing this, I'm just talking now so people can hear me, so you don't have to listen to this anymore. Slide 8. In slide 8, you needed a few things. First of all, how to find the slope. We can use rise over run or the slope formula. How do you write equations? You can go with slope intercept. Where m is the slope and b is the y-intercept. Or you can go with point slope form. Okay, so that'd be y minus y1 equals m times x minus x1. And there are your formulas. Okay. Anybody want to listen to that lesson again? I'll just put it online.